Everybody, tonight I have a problem that could probably be characterized as direct translation, a direct translation word problem. Uh, you just follow your nose, you write down what it says, and then you appeal to whatever algebra that might be available to solve the problem. So this is called a direct translation word problem. I guess all of them are that to some extent, but you're converting the English into just mathematical statements, and again trying to access the necessary results to help you get through it. Okay, so again, this is a direct translation. I get the spelling right there. All right, now, so let's get busy directly translating. This says the difference of two numbers is 4. I didn't specify that the numbers were integers or real numbers. In math just kind of takes care of itself on these problems a lot of times. So anyway, if x would be the largest number right here, so x minus y is equal to 4. They also specify that the difference of the cubes of the two numbers is 100. So that's what I wrote down right here. All right. Now, so at this point, it's been directly translated. Now, at this stage also, you need to pull up this result, the difference of two cubes. This is fairly well known. It's not quite as common as, say, the difference of two squares. But what you get here, x minus y times this trinomial, you would actually get 6 distinct terms, but it turns out 4 of them cancel out because of the presence of this tick-tock minus sign right here, okay? And so now what we do, we fill in the blanks. Well, x minus y is equal to 4. X minus y gets replaced by 4 right here. The difference of the two cubes is 100. It appears right there. Now we can see right here at this point, we're done with the x cubed minus y cubed piece. If we divide through by 4, we get this statement that you see right here. Divide both sides. Again, we just dump this slave right here. Divide by 4 and you get x squared plus xy plus y squared is equal to 25. All right, now this is a single equation and two unknowns, but we can use this original statement to get it as a single equation with just one unknown. Notice that you can write y is equal to x minus 4 right here. Y, you can rewrite this, and it's useful. You could do it either way, but you can rewrite this as y is equal to x minus 4. Okay, and that's precisely what we did down here. We replaced every occurrence of y with x minus 4, and this leads to some straightforward algebra. Again, you can check it out. Maybe I left out some steps here, but x squared here, and x squared pops out of this to give you 3x squared. This gives you minus 4x. This gives you minus 8x, which results in the minus 12x term. Minus 4 squared is 16, equal to 25. Now, when you subtract 25 from 16, you get minus 9, and if you divide by 3, you get this quadratic expression right here that is not amenable to the quadratic formula. You can look at the discriminant to determine that. You would get, 16 squared, you'd get 28, right? And so 28 is not a perfect square for the discriminant. However, you can do something called complete the square. Notice right here, I just added 7 to both sides, okay? I add 7 to both sides plus 7. And that's motivated by the fact that it turns the left-hand side into a perfect square trinomial. Okay, so you get plus 7 right here. This piece right here becomes x minus 2 quantity squared. X minus 2 quantity squared is equal to 7. Equals 7. Okay, now that's nice. This is called completing the square. Again, and adding 7 takes care of business. Now, if you take the plus and minus square roots right here, you get x minus 2 is equal to plus or minus the square root of 7. Plus minus square root of 7. All right, and then so what that results in is x is equal to 2 plus or minus. Oh, that should be the square root of 7 right there. Sorry. Let me erase that. 2 plus or minus square root of 7. All right, and so right here, 2 plus or minus root 7. Okay, now remember, x was the, God, I keep doing that. Let me erase that again. Okay, so that's 2 plus or minus square root of 7. Okay, now, what does that mean? Okay, well, it said x is the larger number, and so what you would get is a couple of possibilities here. One possibility would be 2 plus root 7. Now remember, the difference, this would be the larger number, right? X was the larger number if you remember the setup, right? X was the larger number the way we set this up, right? X was arbitrarily chosen to be the largest number, all right? And so what happens right here, if you subtract 4 from that, you would get minus 4, minus 2, excuse me, plus root 7. All right. And again, you can see that those two numbers are separated by 4, right? Those two numbers are separated by 4, but also we had 2 minus root 7, right? 2 minus root 7 is another possibility. That could also be your largest number. Okay, and then if you subtract 4 from that, you would get minus 2 minus root 7. So both of these numbers, the problem was stated kind of in an open way. There's not a unique solution in this particular case. There are exactly 2 numbers, or 4 numbers, however you want to look at it. And you guys, again, it's clear that this number right here is 4 bigger than this number. In a similar fashion, this number is 4 larger than this number, right? Okay. And there are differences, and the algebra up here has shown that the difference of the cubes is 100. But anyway, these are the 2 solutions, folks. This pair of numbers meets the criterion, and this pair of numbers meets the criterion. So let me circle that. And I'm rooting for the Miami Heat. See y'all later.